In example 2, we're going to solve word problems using a system of linear inequalities. It says a gardener will use up to 180 square feet for planting flowers and vegetables. He wants the area used for vegetables to be at least 3 times the area used for flowers. Let X denote the area in square feet used for flowers. Let Y denote the area in square feet used for vegetables. Shade the region corresponding to all values of X and Y that satisfy these requirements. So what we're going to do is we're going to start by reiterating our variables. So let's write those down so we know what we're talking about. We know X is equal to the area for flowers. And we know that Y is equal to the area for vegetables. Then what we have to do is come up with our inequalities that we want to write down. The first thing that we should notice is that our area for flowers and our area for vegetables can never be a negative number. And since it can never be a negative number, we have to let ourselves know that X always has to be greater than or equal to 0, and Y in this case also has to be greater than or equal to 0. We don't want those negative numbers to come up. Then if we go ahead and look at the first sentence here, it says a gardener will use up to 180 square feet for planting flowers and vegetables. So that means if we're using up to 180 square feet, the area for flowers and the area for vegetables has to be 180 or less. So if we write that down, that would look like X plus Y is less than or equal to 180. And then we have, he wants the area used for vegetables to be at least 3 times the area used for flowers. So we're going to take the area for vegetables, which is Y. At least means it wants to be 3 times or more. So we want greater than or equal to 3x. Then what we want to do is we want to graph these inequalities. So the first thing we can graph is x is greater than or equal to 0. When x is greater than or equal to 0, that's just a vertical line. When you do your graphing, you're going to want to use as straight a line as you can. So using your ID is a great thing for a straight edge. If you don't have your ID, if you want to get a little ruler, something that's going to make your lines very straight. Because as we get more complicated, we're going to be looking a lot at those intersection points, which you're going to want to be able to tell. And the straighter the line, the more accurate those intersection points are going to be. So let's go ahead and graph that. It's going to be a vertical line, and I apologize, my lines, I don't have a straight edge I can use for my videos, so I'm going to do the best I can. Yours, though, should look a lot better, as you will be able to use that straight edge. Then I want to graph y is greater than or equal to 0. Y equals 0 is a horizontal line at that x-axis. And when we're talking about the inequalities, x is greater than or equal to 0 means we're looking at this whole area to the right of that line, and y greater than or equal to 0 means we're looking up, all that area. So basically these two lines that we've graphed have said our answer, our shading must happen somewhere in that first quadrant. Then what we're going to do is we're going to go ahead and graph x plus y is less than or equal to 180. If I graph that, the first thing I want to do is I want to get it set equal to y. So I want to get y by itself. To do that, I need to subtract x. And I get y is less than or equal to 180 minus x. If I take a look at this graph, my y-intercept here is 180. I cannot count up 180. So when you're doing these problems, sometimes you'll be able to go up by 1 and sometimes you won't. This is a case where if I'm going up by 180, I'm going to need to change what I'm going up by over here. So I'm going to go up by 10. You don't have to go up by 10. You could go up by whatever you need to in order to fit the numbers that you want. So if I go up by 10, I'm going to have 10, 20, 30, 40, here's 50, 60, 70, 80, 90, here's 100, 10, 20, 30, 40, here's 150, 60, 70, 80, 90, and then here's 200. And this is 150. Okay. So as I graph this line, I'm also going to think about my x-axis. I'm going to go up by 10s on that as well. I don't have to. So here's 10, 20, 30, 40, 50, 60, 70, 80, 90. Here's 100, 10, 20, 30, 40, 150. 60, 70, 80, 90, and then 200. Okay, if you wanted to go up by 20s, that's fine, 25. However, whatever makes sense for you, as long as you can get the most out of your graph. So if I go ahead and graph my y-intercept, it's going to be 0 and then 180. So that's going to be right here. And then what I want is I want to get as many points on that line as I can to make it as accurate as possible. Well, my slope here is -1, but remember my x's are not going up by 1s. So I don't necessarily want to use my slope. But I'm going to show you something on the graphing calculator that might help. So let me get the graphing calculator on. Okay, so we have our graphing calculator up there now. What I want you to do is go to your y equals, and we're going to type in our inequality that we have, which is 180 minus x. And as I take a look at my graph down here, I have it going up by 10s. So I'm going to have my graph going up by 10 as well, so my table I don't have to scroll through as many points. So what I'm going to do is I'm going to go to my table set, which is right here. It's in blue above the window key. So I have to hit second first, and then that window key. I'm going to start it at 0, which is where my graph is starting over here. And I'm going to go up by 10. So this little triangle here with the table set, that indicates how much your table is going to go up by. And I want mine to go up by 10. Now if I go to my table function, I hit second and graph, my table now goes up by 10, so I don't have to scroll through as many numbers. So we have 0, 180. We also have the point 10, 170, so let's plot that point. That's going to be right here. And then I've kind of labeled down here 10, 50, 100, 150. Let's start looking at those points. That'll give me quite a bit of points that I can go through and graph. So if I go here, I have 50 goes with 130, so I can go to 50, and then up to 130. Then I get 100, so maybe I'll scroll up to 100 here, and that has 80. So that's going to be right there. If I look at 150 on my graphing calculator, that gives me 30. And if I can get an x-intercept, that would be great. So let's keep scrolling down. My x-intercept is going to be when y is 0, and that happens at 180, 0. So let's go ahead and graph that. And then I'm going to draw on my line. Remember, you want to get your line as straight as you can. Use that straight edge if possible. And then I have my last line that I need to graph, which is y is greater than or equal to 3x. So if I take a look at this line, my y-intercept is 0. So I'm going to start with a y-intercept at 0, 0. And I'm going to do the same thing I did over here. I'm going to go to my y equals, clear that out, and I'm going to type in my 3x. If I go to my table of values, I can go back to the beginning if I want. I have my 0, 0. Then maybe I'll do 10 and 30. I'll go back to the 50, has 150. So that's up here. And then if I look, I have 70, 210. Well, if you take a look at the graph, my graph only goes up to 200. So that one's not going to fit. So the last one I have that's going to fit is this 60, 180. So let's go ahead and graph that. So I have 60 and then 180, which is right here. And again, your line should be a little bit straighter than mine. And then what I want to do is I want to look and see where my area is that I want to shade. So if I look at the area where I want to shade, I'm going to come back to all my inequalities. This one says that x is greater than or equal to 0. So I know I'm somewhere over here to the right. Y is greater than or equal to 0, so I know I'm somewhere up here. Again, these two just tell me I'm in the first quadrant. And then if I take a look at this graph right here, the green one, it says y is less than or equal to 180. So as I'm looking at my graph, I want to shade less than that, which means I want to shade underneath it. The easiest thing to do sometimes is to think about somebody walking on that graph. So if I think about a guy walking on that graph, he's going to be walking on the top of it. If I have a less than, I want to go underneath my guy that's walking. So less than that green line is going to be under here. So I'm looking currently at this whole area here. So I'm marked off by the purple, the red, and the green. So I'm under in this triangle. Then I have to take a look at this one. Y is greater than or equal to 3x. So again, if I think about my guy walking, where would I draw that guy walking on that graph? And I would draw him on this side if he was going to walk. That's the top of my line. So if I want greater than, that means I want above that blue line. So if I have to be underneath the green and above the blue, I'm looking at this area in here. So I'm going to shade in this whole area in here. If you have any questions, please let me know.